Hello dear students, this is 10th class mathematics, the chapter number 5, arithmetic progressions. In this video, we will learn the most important 4-mark questions given in SCERT question bank. And also these questions are very much important public examinations. We mentioned textbook exercise question numbers for verification, for your simple verification.
My dear students, this is question number 6. Check whether minus 150 is a term of the arithmetic progression 11, 8, 5, 2 and so on. I shall repeat the question. Check whether minus 150 is a term of the arithmetic progression 11, 8, 5, 2 and so on. Did you understand the question? Yes. Look at the arithmetic progression given. The arithmetic progression is the first term is 11, second term is 8, third term is 5, fourth term is 2. Like this, if we list out all the terms, can you get minus 150 as a term here? Or sometimes you may not get minus 150, you may have minus 149, so that next term will be minus 153, like that. Okay. Now we have to verify whether minus 150 is present in this sequence or in this progression, or minus 150 does not present. We have to verify. Clear now? Good. Now in order to solve this, in order to verify whether minus 150 is a term of it or not, first of all let us consider the arithmetic progression. The given arithmetic progression is, the given AP is 11, 8, 5, 2, and let us assume that minus 50, minus 150 is also there. Then for this arithmetic progression, what is the first term? Yes, good. First term is denoted by A and this value is 11, A is equal to 11. And common difference. Common difference is nothing but the difference between any two successive terms. Here we consider A2 minus A1. Second term minus first term, that is 8 minus 11. What is 8 minus 11? Yes, minus 3. Therefore, the common difference is minus 3. And let us assume that this minus 150 is a term of this arithmetic progression, and let it be an, nth term. That is an is equal to minus 150. Now what is the formula to find nth term of an AP? Yes, an is equal to a plus n minus 1 into d. Now let us substitute the known values. We know the a value and we know the common difference and we know the total an value, and let us find the n value. Okay. A is 11 plus n minus 1 into common difference minus 3 is equal to, let it equate it to minus 150. Now take this plus 11 to other side. N minus 1 into minus 3 is equal to minus 150 plus 11 other side minus 11. Minus 150 minus 11 is minus 161. And minus 1 into minus 3 is minus 161. Or n minus 1 is equal to, take this minus 3 to other side. Here this multiplies this n minus 1, other side should divide this. Therefore, n minus 1 is equal to minus 161 by minus 3. Minus by minus is plus. And n minus 1 is equal to plus 161 by 3. This minus 1 other side plus 1. Now take LCM. LCM is 3. 161 plus 3 ones 3. What is 161 plus 3? Good. It is 164 by 3. N is the number of the term. Number of the term is always either the first term or second term, third term, fourth term, fifth term or 10th term or 100th term or 99th term or 121 term. Means the number of the term should always be a positive integer. But here we get the number of the term as a fraction. It is not an integer, it is just a fraction. There should not be any fraction for the value of n. There should not be a decimal number. The number of the term should always be a positive integer. But since 164 by 3 is not a positive integer, this minus 150 is not a term in the given arithmetic progression. Is it clear? Good. Now let us solve question number 7. Here is question number 7. Look here. Find the 31st term of the AP whose 11th term is 38 and 16th term is 73. I shall repeat. Find the 31st term of the arithmetic progression whose 11th term is 38 and 16th term is 73. Here look at the question. We have given two values. We have given the 11th term value, that is A11 is equal to 38, and we have given the 16th term value, that is A16 is equal to 73. Now what to find? We have to find the 31st term, that is you have to find A31 value. Okay, we have given A11, we have given A16, and you have to find A31. Good. Now here in this solution, let us write what is given first of all. We have given the 11th term, that is A11 is equal to 38, and 16th term, that is A16 is equal to 73. Now what is the formula to find AN? AN is A plus n minus 1 into D. Similarly, A11 means A plus 11 minus 1, 10D. A plus 10D is equal to 38. And A16 means A plus 15D is equal to 73. These two are the equations. We have to subtract this 15D from 10D. That is 10D minus 15D is minus 5D. And we have to subtract 73 from 38. That is 38 minus 73 is minus 35. Minus 5D is minus 35. Then D is equal to minus 35 by minus 5 is 35 by 5. And 5 in 35 7 times. Therefore D is equal to 7. Now substitute D is equal to 7 in equation 1. If you substitute D is equal to 7 in equation 1, 1 means A plus 10D is 38. A plus 10D is 38. Substitute D is equal to 7. A plus 10 into 7 is equal to 38. Or A plus 10 7 70. Take this 70 to other side. Plus 38 minus 70. Therefore, A is equal to 38 minus 70, that is minus 32. Now we have A value and we have D value also. If you know A value and D value, you can find any term. Now I have to find here 31st term. Therefore, 31st term is A plus n minus 1. 31 minus 1 is 30 into D. A value, substitute A value minus 32 plus 30 into substitute D value is 7. Minus 32 plus 37s, 3 7s 21 and 0, that is 270. Therefore, A31 is equal to minus 32 plus 210. If you subtract 32 from 210, you will get 178. Therefore, 31st term of the given arithmetic progression is 178. Now let us look at question number 13. Here is question number 13. How many 3-digit numbers are divisible by 7? I shall repeat. How many 3-digit numbers are divisible by 13? 3-digit numbers. What is the least 3-digit number? Yes, the least 3-digit number is 100. And what is the greatest 3-digit number? Yes, the largest 3-digit number is 999, isn't it? Okay. Now out of or from 100 to 999, how many numbers are divisible by 7? We have to find out. The 3-digit numbers which are divisible by 7 are, if we consider the first 3-digit number 100, 100 is not divisible by 7. Then go for 101, it is not divisible. Similarly, like that, if you check, the first 3-digit number that is divisible by 7 is 105. Next one is 112, 119 and so on. The last 3-digit number that is divisible by 7 is 994. Here if you observe that this is an arithmetic progression, as the difference between any two successive terms is same, this is AP. Okay. In this arithmetic progression, the first term A is equal to 105 and common difference D is A2 minus A1, 112 minus 105 is 7. Common difference is 7, D is equal to 7 and A is equal to 105. And we know that this is some nth term. Nth term is 994. And let us find n value now. Let us assume that the last term 994 is some nth term. This is the first term, it is the second term, it is the third term and it is the nth term. In order to find out how many 3-digit numbers are divisible by 7, it is the first 3-digit number divisible by 7. It is the second 3-digit number and it is the third 3-digit number. Similarly, it is the nth 3-digit number. Let us find the nth value now, n value now. Nth term of an AP is given by an is equal to a plus n minus 1 into d, isn't it? Good. Now here substitute a value. A value is 105 plus n minus 1. We have to find out n value. Therefore, write n as it is, n minus 1 into d. D is 7 is equal to the total value of this term is 994. So equate it to 994. Then n minus 1 into 7 is equal to 994 plus 105 other side minus 105. If you subtract 105 from 994, you will get 889. So n minus 1 into 7 is 889, or n minus 1 is equal to 889 divided by this 7. This 7 in 889, 127 times. Means n minus 1 is equal to 127 and n is equal to 127 minus 1 other side plus 1, or n is equal to 128. So there are 128 3-digit numbers that are divisible by 7. This is question number 14 and exercise 5.2. Look at this question. How many multiples of 4 lies between 10 and 250? I shall repeat. How many multiples of 4 lies between 10 and 250? Here if you observe this, do you know what is meant by multiple of 4? Yes. What are the multiples of 4? Yes, 4 1s are 4, 4 2s are 8, 4 3s are 12. So 4, 8, 12, 16, 20, 24, all these are multiples of 4s. Out of which, what is the first multiple of 4 after 10? Yes, the multiple of 4 after 10 is 12. 10 is not divisible by 4, 11 is not divisible by 4, and the next number 12. Yes, 12 is divisible by 4. Therefore, the first multiple of 4 between 10 and 250 is 12. The multiples are 12, 16, 20 and so on. This 250 is not divisible by 4 and its previous number 249 is not divisible and 248 is divisible by 4. Therefore, the multiples of 4 between 10 and 250 are 12, 16, 20 and so on 248. Now we have to find out how many such multiples are there. Here in this arithmetic progression, a is equal to 12, first term a is equal to 12, and common difference. Do you know how to find common difference? Yes, it is nothing but the difference between any two successive terms, that is d is equal to a2 minus a1, that is 16 minus 12 is 4, and the last term or nth term of this progression is 248, and let us find n value now. Okay, assume that this 248 is an. What is the formula to find an? An is equal to a plus n minus 1 into d. Here substitute a value is 12, d value is 4, and let us find n value now. A means 12 plus n minus 1 into common difference 4 is equal to its value 248. Or n minus 1 into 4 is equal to 248 plus 12 other side minus 12. 248 minus 12 is 236. Here this 4 multiplies other side should divide. Therefore n minus 1 is equal to 236 divided by 4. 4 in 236 59 times. That is n minus 1 is equal to 59 and n is equal to 59 minus 1 other side plus 1 and n is equal to 60. Therefore how many multiples are there? Yes, there are 60 multiples of 4 are there between 10 and 250. Is it clear? Good. Now look at question number 15 now. As this is question number 15. For what value of n are the terms of two APs 63, 65, 67 and so on, and 3, 10, 17 and so on are equal? I shall repeat. For what value of n are the terms of two APs 63, 65, 67 and so on, and 3, 10, 17 and so on are equal? Here we have two APs, one is 63, 65, 67 and so on, and the second is 3, 10, 17 and so on, and for these two APs a particular term is equal. The terms of two APs are equal. Here a particular term of this AP is equal to the same value of a particular term of this AP. Now we have to find that n value. Okay. Now let us consider the first AP 63, 65, 67 and so on, and let us consider the second AP 3, 10, 17 and so on. And in the first case a is equal to 63 and common difference is 65 minus 63, that is 2. And in the second AP, the first term, let us name it as some b is equal to 3, and common difference 10 minus 3 is equal to 7. This is the first AP. Use first term is 63 and common difference is 2. And in the second AP, first term is 3 and the common difference is 7. But it is given that nth terms are equal. Nth term of the first AP is equal to nth term of the second AP. That is an is equal to bn. Now what is the formula for an? A plus n minus 1 into d. What is the formula for bn? B plus n minus 1 into d. Now let us substitute the values. What is a value? 63 plus n minus 1 and d value is 2. This is equal to b value is 3 plus n minus 1 and here d value is 7. Okay. 63 plus 2 into n is 2n minus 2 ones 2 is equal to 3. 7 into n in 7n minus 1 into 7 is minus 7. Now bring all n terms to one side. 2n minus 7n is equal to 3 minus 7 is minus 4. 63 minus 2 is 61 and this 61 plus 61 other side minus 61. What is plus 2n and minus 7n? Plus 2n minus 7n is minus 5n. Minus 4 minus 61 is minus 65. And n is equal to 65 by 5. 5 in 65, 13 times. Therefore, the 13th term of both these APs are equal. Here n is equal to 13. Good. Thank you. Thank you one and all.